Hello my dear students, welcome again. So in the last class we discussed about those operator precedents, and before that we already studied the Boolean postulates and theorems and all. The important topic for now for this Boolean algebra is functions. Okay, here we call it as a Boolean functions. Then the first question comes to our mind is, what is this Boolean functions? To understand these functions, we have to have some idea about variable, and I hope that you already know what is variables, like whatever may be the variables which can be represented with the help of alphabets like x, y or something. Here we call it as a binary variable. That function can be defined as a binary variable can take the values either 0 or 1 in this Boolean algebra, right? The same way, if we operated anything on these variables, the result is obtained either in the form of 0 or in the form of 1. That is, I can call it as a function. To make it very clear, I will tell you once again, a Boolean function is an, if you want you can note it down, Boolean function is an expression, okay, it is an expression formed with the binary variable. Boolean function is nothing but it is an expression formed with a binary variable. Okay, say for example, if I write x, yes, this is a variable, y, yes, this is also a variable. We are calling function as an expression formed with the binary variables, but the two binary operators should be required. Say for example, the binary operator are like this, or, and might be not, right? These are the operators here. So if I write x plus or x or y, I can call, or this is also termed as x plus y. Usually in Boolean algebra we call this as x. How we can pronounce this? X or y. It means that x is ORed with y, like that we can call. So this x plus y, two variables such as x and y are operated with a OR operator. So this is also, or this can be called as a function. So I will write this as f equals to x plus y, right? F equals to x plus y can be called as a Boolean function. The same way you can write f equals to, or f1 you can take f1 equals to x dot y. Yes, this is also Boolean function, right? If I write three variable f2 equals to x y z, yes, this is also Boolean function. And not only these simple variables x, y, z, those variables may be primed or unprimed. Primed or unprimed in the sense, the variable may be x prime, y prime, z prime, or you can call it as x bar, y bar, z bar. These both are same here. You can call prime or bar, both are same only. Your function may consist of, say if I write f3, I am writing 1, 2, 3 because these are the different functions from these. So f3 might be x, y, z bar. Yes, this is also function. The same way if I write f4 equals to x plus y bar z, yes, this can be a function. This is how we can understand the function in the Boolean algebra. The main important thing right here is the functions always give the result. You remember this? The function always gives the result either 0 or 1, because the Boolean algebra only provide you as a result whether in the form of 0 or in the form of 1. So obviously this function can be given as output as 0 or 1. Say if I write f equals to x plus y, as you already know that if I want to write the truth table for this function f equals to x plus y, how many combination I have to write? If there are two variables, then 2 to the power 2 means 4 combinations, right? X and y, two variables are there, so that x, y, 0, 0, 1, 1, 0, 1, 0, 1. What is the function now? F equals to x plus y. Uh, Before that, x plus y itself is a basic gate, that is known as OR gate is there. As you know, that symbol is like this, right? So to make you understand the function, I am taking the same example. So what you will get the result as function f? Function f means what? Here you will get 0, here it is 1, here it is 1, here it is 1. What we understood by this truth table? Here we understand that f equals to 0 whenever both x and y are operated with the OR operator. See, it means that 0 plus 0 you will get 0. It means function will be 0 whenever both the inputs are 0. Function may be 1 whenever any one of the input is high, that is f equals to 1. In this case also f equals to 1, in this case also f equals to 1. This is the way to represent the functions. Okay, you understand that always the function will give the result either in the form of 0 or in the form of 1. If I continue that discussion now, if your function consists of, say for example f is equals to x plus yz, how many combination I need to write? Here x is one variable, y is another variable, z is also another variable. The total number of variables can be written here is 3, right? The formula is 2 to the power 3, 8 combinations we need to write. Okay, so just I will write a truth table for this function now. That is, function is what? F equals to x plus yz. So I will write x, y, z, right? Here f. Here f in the sense what? F is nothing but x plus yz. You understand? I am not writing here because this is the way. Here if I write x, okay, here f represents x plus yz. Here f in the sense what? F is equal to x plus yz, it means, right? So to form this function, as you already know, we can write table. Before that, I have to write one more combination, that is yz. Then I can write easily the function, that is f. So I will write the values 0, 0, okay, 1, 1, sorry, 0, 0, 0, 0, 1, 1, 1, 1, right? Here 0, 0, 1, 1, 0, 0, 1, 1. In the z, 0, 1, 0, 1, 0, 1 and 0, 1, right? And you operate yz, this is 0, this is 0, this is 0, this is 1, this is 0, this is 0, this is 0 and this is 1. By this truth table, how you can write f? F is nothing but, what is the value of f? F is equal to x plus yz. Then you have to consider x and you have to OR this with this, right? 0 plus 0, 0, this is 0, this is 0, this is 1, this is 1, this is 1, this is 1, this is 1. This is how the function, or simply you can call the expression, can be written in the form of truth table. What it tells, as I told, function always have the output or result in the form of either 0 or 1. You observe here, function getting 0 here, like that, 1 are here. It means that function will be 0 whenever all the inputs are 0. In case of this expression I am telling, that is, all the inputs are zeros, only with this function, right? This is not true in all the functions. Whatever the function I have considered here, based on that function, whenever all the inputs are 0, at that time function will be 0. You consider here, if I consider this row, x is 0, y is 0, right? Yz is 0. I am not considering this because I already operated only the function is formed with the help of xy and yz, right? See, here also it is 0, it is 0, it is 0, right? Then 0. If any one of the input is high, then always the function results 1. Function equals to 1. See now, here it is 1. Yes, you get the result as 1. Here if you have 1, you will get the result as 1. Sorry, this is the result. Here you have 1, you will get the result as 1. The same way you can write any function in the form of truth table. I hope this is clear to you, right? This is all about function. Function may consist of primed or unprimed variable. Say for example, if I write one more function here, say if I can also write f equals to x prime plus yz. This is also function. What it means? X is prime, means if the input is 0, that x input become 1. That is what it means. And one more thing I have to tell you right here, that is, you can also construct, we can also, if you want you can note it down, we can also construct, okay, logic gate or logic diagram for the given function. Logic diagram for the given function. And how to write the logic diagram for this yz? You know, if multiplication comes, what we do? We use AND gate. For addition, we use OR gate, right? According to that, I can construct a logic diagram for this function. So, what is our function now? I will write that logic diagram here. F equals to x plus yz. F equals to x plus yz, right? And how to write the logic diagram for this? For this, you know, yz is ANDed, right? Yz, it means that multiplied. Here it is ANDed. Y is ANDed with the z. So that first I will take one AND gate here, right? With that I have to AND z. So I will take one input, I label it as y. I will take one more input, I label it as z. Correct? What will be the output for here? If you consider only this part, you will get the result as y and z, right? Y dot z you can call. But that y dot z is ORed with x, right? So that I will take one more. Which gate I need to take now? Now you have to take the OR gate, right? This is OR gate. So I will write the input as x. What you will get? Here if you write, you will get yz is here. It means yz is given input now. Here input is x. That means yz plus x. This is our function. This is the logic diagram. If you are getting confusion, you can also write the same code or same logic diagram like this. Say I will write x. Okay. Here I will take AND gate. This is y, this is z. This is the output, that is yz we obtain here. So if I given this yz and x as an input to this OR gate, you will get the function whatever you have given, that is f equals to x plus yz. This is the how you can construct logic diagram for the given function. Okay. What it means? Logic diagram is in the sense these are the gates which are there, or these are the logic gates. If the input is given like this, say 0, 0, 0, means if no voltage is supplied, that is the input right here. Okay, x is 0, y is 0, z is 0, this output will be 0. That is how we understand. If I give the input x as 1, y as 0, z as 0, what will be the output? Here f will give you output as 1. If you can see the table here, if x is 1, y is 0, z is 0, if x is 1, where it is? Okay, here x is 1, output is 1, right? Here I have taken x is 1. The result is often 1. Wherever you have the x is 1, you will get the result as 1. At the same time, if you have x is 0 and y is 1, z is 0, then also you will get result as 1 as a output. This is how you can construct and understand the concept of function. Okay. I give some function and you write a truth table and a logic diagram for that, and you can submit to me. Okay, one function I will give. You can also write the truth table in a single table only. Say for example, if I give f1 equals to x plus y prime z. Okay, f2 equals to x y z bar, f3 equals to x bar y bar z plus x bar y z plus x y bar. Okay, these are the some examples. One more I will give. F4 equals to x y prime plus x prime z. You have to write truth table for these given functions. At the same time, you have to write logic diagram for that. Okay, you can write truth table in a single table. Say for example, all the variables have common, or all the functions have common variables x, y, z, right? In the next column, here you can write function 1 table, function 2, function 3, function 4. You can write the values over here. Okay, you can construct a truth table for all these. Okay, one more question if you have, I think that is for example, x plus y z y bar z is there. How to construct a truth logic diagram for this? That is, you take x variable, y and z are ANDed, right? So I will write AND get here. This is y and this is z. But y is not just y, it is a prime, right? So that what we have to do, this is y bar. For that, you just need to connect not get here and connect to this, and then you connect this both to the OR gate. This is OR gate. Right? This function is equal to x plus y prime z. That is the way you need to do. Okay, I hope this is clear to you. I hope you will do the work. Fine. Thank you.